start by reviewing just some basics of the unit circle. We talked on Monday about standard position for angles. And it sounds like you guys had seen this already in Algebra 2, that 0 degrees is on the positive x-axis here. Positive angles rotate counterclockwise, negative angles rotate clockwise. So why don't we do a quick example of this? Could I get you guys to sketch? Go ahead and draw yourself an XY axis for me. And I'd like you to think through and sketch 120 degrees and where that would be. And then the position also for negative 3 pi over 4. So when I think about 120 degrees, I'd be thinking about, that's 90. I know where 90 is, so I need to rotate around to 90 and then go another, what, 30 on top of that? Will get me to 120. So my thought bubble would be 120, that's 90 plus 30. So I could start at 0, I could rotate in the positive direction, 90, plus another 30. And that would get me 120 degrees, which would be here-ish. Okay, we're going to get better and better at thinking in terms of radians. I know that it's a little uncomfortable at first, but just grit your teeth and bear it for a little while, and before you know, you'll be thinking in radians just as well as you do in degrees. So I don't want you to get in the habit of seeing negative 3 pi over 4 and immediately converting that into degrees. I need you to be able to think in radians. Okay, and here's my thought process for this. I think of that as 3 times pi over 4. And it would be negative 3 times pi over 4. So we are going to rotate, starting at 0, we're going to rotate the opposite direction. But let me tell you how I think through pi over 4. So this is pi, agreed, half of a circle. And if I chop that up into 4 segments, it would look something like that. So each of these is 1 pi over 4. So here we go. I'm going to go negative 1 pi over 4, 2 pi over 4, 3 pi over 4. And that gets me to here. So as you're thinking in radians, start thinking about taking that half circle, that pi, chopping it up into portions, and then just count out those portions. All right, so this next part, I'm not going to give you enough time to write down. We need to keep moving, but we talked about this on Monday. Coterminal angles, the idea that if 2 angles have the same position, then they're called coterminal angles. An example would be like 270 and negative 90. If I rotated positive 270, I'd get to right here. If I rotated negative 90, I'd end up at the same place. 270 and negative 90 are not the same angle, but they have the same position, so they are coterminal angles. So not equal to each other, because negative 90 is not equal to 270. But if you were to graph their positions, you would end up at the same spot. And what we talked about on Monday was, no matter what direction I'm facing, say I'm facing in the direction of this pen, okay, so this is some angle. If I rotate a full 360 degrees, I'm going to end up facing the same direction I was in before, right? And I can rotate 360 degrees either direction as many times as I want. So if we're looking to find coterminal angles, all we need to do is add or subtract either 360 or 2 pi, depending on whether we're dealing with degrees or radians. So adding or subtracting 360 and 2 pi is the key. So I'm going to skip down here to these examples. And what I'm going to ask you to do in these problems is to find me 2 positive and 2 negative coterminal angles. There is a similar problem to this on last year's chapter 4 test. it may be useful to have your calculator out. So I've got a negative angle. If I wanted to find a positive or a negative coterminal angle, what am I going to be doing to this negative 1770? I would probably just start adding or subtracting 360s from it, right? Show you a little trick on these calculators. If you type in your starting value and hit enter, and then type plus 360, then you can just keep hitting enter over and over again, and it'll keep adding 360 to it. All right, so negative 1770, whatever direction that's facing, negative 1410 degrees would be facing in the same direction. So there's one negative, negative 1410. And then you can just keep hitting enter, and it'll just keep adding another 360 to it. So here's another negative one, negative 1050. And enter, there's another one. I already got two negatives, so I'm just going to keep going until I come across a positive. Oh, there we go, 30. Turns out 30 degrees is in the same direction as this. So 30 would be a coterminal angle. And 390. And there we go. We've got two positive, two negative coterminal angles there. And all we had to do was just start at that point and start adding and subtracting 360 from it. Okay. Now, it turns out, you're going to love this, that this is actually easier to do with radians than it is with degrees, because you won't even need a calculator for this. Okay. So check this out. I'm going to take this and I'm going to start adding some 2 pi's to it, right? Because that's a full circle. Okay, so I'm going to do plus 2 pi. Now watch this really quick. I'm going to do plus 2 pi, but I'm not going to think of 2 pi when I'm doing it. I'm going to think of a different version of 2 pi that would be more convenient since I'm adding it to a fraction that has a denominator of 6. Anybody know what the version of 2 pi that I'm going to hold in my head while I'm doing this is? 12 pi over 6. So I'm thinking 12 pi over 6 because that is 2 pi, right? So I go 23 pi over 6 plus 12 pi over 6 would get me 35 pi over 6, and we didn't even need a calculator. I think we're probably going to be able to go the opposite direction and get another positive one. So let's try subtracting. So I'm going back to 23 pi over 6, and this time I'm going to subtract 12 pi over 6, and that's going to get me 11 pi over 6. There's another positive one. So here I did minus 2 pi, aka 12 pi over 6. And then let's do minus 2 pi again. So minus 12 pi over 6 would get me to negative 1 pi over 6. Minus 12 pi over 6 again will get me to negative 13 pi over 6. See how easy that is? Now, are you always going to be thinking 12 pi over 6? It depends on what your denominator is. If we were doing something like 3 pi over 4, so if we're thinking of over 4, then I want to be thinking about adding, what would that be? 8 pi over 6 would be the same as 2 pi. So far, so good? You guys are doing awesome. Any questions? All right, let's keep it rolling. Unit circle. Don't know how much of this is going to be familiar to you. I'm going to give you some good facts about the unit circle that are going to make your life a little bit easier here. So the unit circle is defined as a circle with a radius of 1. I should put on here also it's centered at the origin. So I've drawn this, it just didn't turn out very dark. So I'm going to darken it and make it a little more potato-like. So this is great because last year when I taught Precalc, my students had not seen the unit circle at all. because the previous year was pandemic and everything, right? But you guys did see a little bit of unit circle. Did you guys learn about the relationship between X, Y coordinates and cosine and sine? Okay, this is gonna be huge. It's gonna be something that we're gonna use again and again and again. It turns out if we are on the unit circle and we pick off a point on the unit circle, well, you guys are still ready. Let me pause because I want you to soak this in. This is going to be really important. Bless you. Centered at 0, 0, centered at the origin. All right, ready to go here? All right, so it turns out if I pick a point on the unit circle, and I'm going to go ahead and pick this one right here. Give me a rough estimate of the angle that I would be dealing with at that location. What would this angle be in degrees? Oh, 120, that's what I was shooting for. Okay. We are of like mind. You guys have your calculators with you? Could you get them out and could you type into your calculator cosine 120? We are in degree mode. This is degrees. Cosine 120. Negative a half. Negative a half. Look at this point right here. Man, this turned out pretty well, actually. What's the x coordinate of this point, roughly? It is negative a half, isn't it? This point that we drew at 120 degrees. The x coordinate of this point, right? Because here is 1. So this would be 0.2, 0.4, 0.6, 0.8. So it is about 0.5, isn't it? Negative 0.5. What is the y coordinate of this point? If you had to estimate it looking here, just at my graph up here, which is potato-ish, so it's not going to be exact, but y coordinate would be 0.2, 0.4, 0.6, 0.8, not quite 0.9, somewhere between 0.8 and 0.9. Agreed? Go ahead and put in the sine of 120. 0.866, and that is not a coincidence. Okay, this is going to be true for anything. So it turns out that when you pick a point on the unit circle, whatever that angle is, your x coordinate of that point is going to match the cosine of that angle. In this case, it was 120 degrees. And your y coordinate is going to match the sine of that angle, which I put theta, but I meant to put 120 there. Fix that. And this is one of the key things about the unit circle. And we're going to use this in a second. Well, we'll get to that in a second. But we said that our x was about, well, it was negative 0.5, and our y ended up being about 0.86, 0.87, I guess, if we round correctly, but close enough. So cosine goes with the x coordinates, and sine goes with the y coordinates. Okay, and you're going to want to get that like cemented in your brain as soon as you possibly can, because we're going to be thinking through a lot of stuff. So that's pretty important because it tells us some things about sine and cosine. For example, I would not expect you right now to know what the sine of 200 degrees is. 200 degrees would be about right here, right? I would not expect you to know what the sine of 200 degrees is, but I expect you to be able to tell me whether the sine of 200 is positive or negative. Which one is it? So remember, sine goes with the y coordinate. What would the y coordinate for a point at 200 degrees be? It would be negative, right? What if I asked you for the sine, or what if I asked you for the sine, S-I-G-N, positive or negative, of the tangent of 200 degrees? Oh no, we didn't talk about tangent yet. How about cosine of 200 degrees? Is that going to be positive or negative? Negative. What about the cosine of 300 degrees? That'd be over here someplace. That would be positive because the x coordinate is positive and x goes with cosine, right? All right, now the convenient thing is, here's a little bonus for you, and we'll use this quite a bit in chapter 5. Tangent is equal to sine over cosine. So if you know sine and cosine, then you can figure out tangent. So let's go back to 200 really quick. We said that for 200, the cosine and sine were both negative, right? Because the x and y coordinates would both be negative. So if I made a fraction out of two negative numbers, what's tangent going to end up being? Tangent's going to end up being positive here. And it would be for any angle in this quadrant. Have you guys seen this before? Okay, so it's kind of, it's some familiarity with it, but we're going to really nail it this time. All right, and by the way, if tangent is sine over cosine, so sine is the y coordinate, cosine is the x coordinate, what does tangent have to do with this line segment or point? It's the y coordinate over the x coordinate. That is the rise over run. Tangent would be the slope of that line, right? Because it's the rise over the run. Agreed? All right. So here we go. Unit circle signs. All students take calculus. You guys ever heard of all students take calculus? So do me a favor, draw me an XY axis. Go ahead and label your angles going around. I'm going to give you a minute to do this. I knew this was going to take a minute. And we're going to talk about positives and negatives in our unit circle. We'll just fall back on what we just learned a second ago. And then we just got a couple examples after this. So we're looking good on time. Yes, absolutely. I'm going to pause here for a second. Now, just so you know, after each of these things, I'm going to be putting a plus or a minus or a 0. Okay. So in a minute, we're going to put a little plus here and we'll talk through it. And we're going to do that for each of the sines, cosines, and tangents. So what we're looking for here is kind of a visual guide for inside of each quadrant, which ones are positive and which ones are negative. And then also at these cardinal directions, these are called the quadrantiles. Quadrantiles, they're the x and y axes. Which ones are positive, which ones are negative, and actually some of them are going to be 0, and we're going to run into undefined a couple times too. Give you about another minute or so to get that down. You're just writing sine, cosine, tangent over and over again about 8 times each. I suppose you could abbreviate SCT. Anybody do that? That'd be very mathematician of you. There is, yep. I'm a little off. A little too big, yes. If you're done, if you could go ahead and start filling them in, I want you to think about what we just talked about. Remember, sine goes with, let's make a little note up here. Cosine goes with what? The x or the y coordinate? Cosine goes with the x, sine goes with the y, and tangent is equal to sine over cosine, or y over x. So in this first quadrant, think about any point in this quadrant. Would you agree that both the x and the y coordinates are going to be positive in the first quadrant? So that means sine and cosine are both positive. And which means tangent is too, because tangent is sine divided by cosine. So tangent would also be positive. All right, second quadrant, x's and y's are not both positive. One is. The y would be positive here, right? So that means sine is positive here. But the x coordinates are all negative here, so that means cosine would be negative. And if we were to make a fraction out of a positive and negative number, we're going to get a tangent of minus. All right, we already talked about this quadrant. We said both the x and the y. So the x was cosine and the y was sine. We said they were both negative. And sine over cosine, negative over negative is going to be a positive tangent. In this quadrant, the x coordinates are positive, so the cosine would be positive, but the y coordinates are negative, so the sine would be negative. And then tangent is sine over cosine, negative divided by positive would be negative. We get it? So there's a little mnemonic to help you remember this. All students take calculus. All students take calculus, and here's how it works. All of your trig functions are positive in the first quadrant. Sine is the only one that's positive in the second quadrant. Tangent's the only one positive in the third quadrant. Cosine is the only one positive in the fourth quadrant. All students take calculus. Many of you, I'm going to see on our chapter 4 test, you're going to have this at the top of one or two of your pages. All right, can we talk about the quadrantals? Are we feeling good about the quadrants? The quadrantals are the barriers in between the quadrants. So think about at 90 degrees. What's going on with our coordinates, our x and y coordinates at 90 degrees? The x coordinate is 0, correct? So that means the cosine would be 0 at 90 degrees. And the y coordinate, if we're on the unit circle, remember the radius is 1, the y coordinate would be 1. So sine would be positive 1, cosine would be 0. And when we go to do tangent, we're going to do sine over cosine. We're going to do 1 divided by 0, which is undefined. If you try to take your calculator right now and type in the tangent of 90, you're going to get an error domain because tangent is undefined at 90. So let's kind of do the same thing here. So at 180, this time my y coordinate is 0, correct? So sine would be 0. The x coordinate would be negative, and it's right on the line there, so it would be 1, negative 1. And tangent would be sine over cosine. 0 over negative 1 is 0. And we can keep going around. Let's see, down here, y coordinate would be negative 1, x coordinate would be 0, tangent negative 1 over 0 is still undefined. Because we can't divide by 0. Great question. Why is negative 1 over 0 undefined? Because we are not allowed to divide by 0. Till next year in calculus. And then you can't actually divide by 0. You just divide by something really, really close to 0. All right. Let's see here. My x coordinate is 1, so cosine's 1. My y coordinate would be 0, so sine 0. Sine over cosine would be tangent, so 0 over 1 is 0. All right. So you're going to get really good at dealing with these and kind of thinking your way through them. But while you're doing your homework, you might want to have this little chart handy. All right. All right, we just got a few more examples. You guys are doing awesome. Thanks for sticking with me. I asked you to start drawing me reference triangles in our last homework assignment. And this is where we're going to learn all about reference triangles. We're going to do 3 examples with reference triangles. And I'm hoping we can squeeze them in here. Got 20 minutes, 18 minutes. So what I need you to know is there's some rules for reference triangles. Reference triangle is a triangle that we draw on the XY axis. The angle position has to be the hypotenuse of our reference triangle. So picture a right triangle. Wherever our angle position is going to be our hypotenuse. Right, that's our long side. One of the legs has to be on the x-axis. So a very common initial mistake that people make is they'll draw their reference triangle attached to the y-axis instead of the x-axis. It's going to cause you some problems. And then your reference angle is going to be at the origin. All right, so we're gonna start with an angle for our first reference triangle. So I'm giving you an angle this time. 4 pi over 3. Let's think our way through this. I'm going to think about my half circle, and I'm going to cut it into thirds, right? So that would be here and here. I'm actually going to need some space down here because I can tell this is bigger. It's going to go past. I'm going to start counting. I'm going to go 1 pi over 3, 2 pi over 3, 3 pi over 3. We're going to go down to here as well. So let me chop those into thirds as well. So starting at 0, moving in the positive direction, we're going to count 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, and we will draw that position right there. And when we draw that angle position, we are creating the hypotenuse of our reference triangle. All right. Now we need to connect that hypotenuse back to the x-axis. Remember, one of our legs has to be along the x-axis. So I'm going to draw a line connecting back to the x-axis. And that's going to be my reference triangle. You feeling all right so far? Hey, this is one of our special triangles, isn't it? Because pi over 3 is how many degrees? That is 60 degrees. So this turns out to be a 60-degree angle right there. That right there is our reference angle. Reference angle. It's the angle that's at the origin, not this one over here, not the 90-degree one. It's the one that's at the origin. So we've got a reference triangle. We got a reference angle. Now your reference angle is always going to end up between 0 and 90. Okay, my reference angle is not 240 degrees. It's 60 degrees. Okay. Now let's practice 30, 60, 90. Can you fill in some numbers going around this bad boy? 1, 2, √3. Sound correct? 1, 2, √3. All right, so this is going to be our general process with a lot of problems. We're going to draw an XY axis. We're going to draw a reference triangle. We're going to get the sides onto our reference triangle. And then before we go on to the next step, this is really important because my students often forget this, and I often forget this too. I'm going to be writing down sine and cotangent for these things. Let's think, before we start thinking about sides, let's think about signs on these, as in positive and negative. If we're dealing with a reference triangle in this quadrant, what did we say sine was in this quadrant? Was it positive or negative? Sine is negative in this. So whatever this answer is, it is going to be negative for sure. So go ahead and draw that negative sign in there right now. I'm going to draw my fraction bar after it. And then cotangent would be what? Well, cotangent and tangent are reciprocals. That doesn't change the sign. So what about in this quadrant? What was tangent? Was tangent positive or negative? Tangent was positive here, so cotangent should also be positive. So I'm going to put a little plus there to remind me that that is going to be positive. And now it's just a matter of sticking some numbers into our fractions and simplifying them. So sine is opposite over hypotenuse, so negative radical 3 over 2. That's already good to go. Cotangent is going to be, now tangent is opposite over adjacent, well, we need to flip that. So adjacent over opposite. So adjacent over opposite would be 1 over √3. And then we'll simplify that and call that, what would that be? √3 over 3, yes, lovely. How are we feeling? All right, let's try another. This one's going to go a little quicker. This time I'm giving you a point. So I'm going to draw my XY axis. I'm going to actually use my grid this time around. 4, -3. So +4, -3. That's this point right here. So when we're going to connect that back to the origin to create our reference triangle. And look up here for a second. I'm going to make a mistake here. I want to show you the common mistake I was talking about a second ago. You don't want to do this. What rule did I just break there? I connected it to the y-axis. When we make a reference triangle, it always needs to connect to the x-axis. So let me get rid of this. So that's going to be the hypotenuse here, and that's going to connect back to the x-axis. And I'll go ahead and call this theta. I don't know what it is right now. That's okay. I don't need to, because all we're doing is finding the sine, cosine, tangent, and such of theta. Well, theta would be a negative angle this time because it's going that direction. And check it out. We've already got two sides of our triangle, right? This is 4 and this is 3. Now we're talking sides of a triangle. That's why I called it 3 instead of -3. It's how long the triangle side is. And who knows their Pythagorean triples? 3, 4, 3, 4, 5, right? We could do Pythagorean theorem to find that 5, but let's just put that 5 in there. Great. So we're about ready to go. But again, just so we don't forget to do it, let's go through sine, cosine, and tangent in this quadrant, and let's label which ones are positive and which ones are negative. In this quadrant, is sine positive or negative? All students take calculus. What's the only thing that's going to be positive in this quadrant? Cosine is going to be positive, which means secant's also going to be positive. That means sine and tangent are both going to be negative. And then we just have to fill in some fractions. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and then flip them. You guys are troopers. I'm throwing a whole lot at you here today. I appreciate your attention. You guys feeling all right? A little overwhelmed? A little overwhelmed. Hey, just so you know, we're gonna do a little review on Friday. You guys are gonna have some time to work through some problems and ask some questions. So just, I'm not gonna throw more stuff at you again on Friday. So if you're feeling, you're probably gonna have some questions. That's all right. We'll get them all sorted out on Friday. Okay. All right, stick with me for one more. You're doing awesome. So this time, I'm not giving you a point. I'm not giving you an angle. I'm giving you two pieces of information about my angle. So these, I like to call these the Sherlock Holmes problems because you got to do some sleuthing to figure out where your angle is going to be. So the big thing that we need is a quadrant to draw our reference triangle in. Once I get a quadrant, I'm going to be able to fill in two sides of that reference triangle with the secant information, right? Then I'll be able to find my third side, and then I can tell you what sine, cosine, tangent, or any of the other ones are. But the tricky part of this problem is figuring out what quadrant are we going to draw that triangle in. So can you take these two pieces of information here and put them together and tell me what quadrant you think it's going to be in? Any ideas? Because we're short on time, I'm going to tell you my thought process. You guys with me? Don't miss this, all right? I'm going to look at this piece of information there. Secant is related to sine, cosine, or tangent. Which one's secant? Secant's related to cosine. When I see that the secant of theta is 5/2, I don't really care so much about the 5/2 as the fact that it's positive. Secant's positive, agreed? Which means that cosine is positive. That's my first piece of information. And my second piece of information comes from this. What does this tell you about tangent? Is it positive or is it negative? Tangent is negative. So there's only one quadrant that has positive cosine and negative tangent, quadrant 4. So let's draw a reference triangle in quadrant 4. So do you guys see how we put those two pieces together to come up with the fact that this is going to be in quadrant 4? That's the only place where cosine is positive and tangent is negative. So I'm going to draw my reference triangle down here in quadrant 4. I don't know theta, but I know it's going to be right there. And then we've got some numbers we can put in there. So secant is what over what? That's hypotenuse over adjacent. So 5/2. All right. And I'm hoping this is looking kind of familiar because we spent a couple homework assignments. Once we have this, and we need to find our third side, and then we can find all this stuff. Really quickly, before we run out of time here, tell me about sine and cotangent, just in terms of positive, negative. Is my answer here going to be positive or negative for sine? Think about what quadrant it's in. My y coordinates in this quadrant are negative, so sine is going to be negative. Remember, sine goes with the y coordinates. And cotangent is just the reciprocal of tangent, so think about tangent in this quadrant. Tangent in this quadrant is also negative, right? So I know I'm going to get negative answers. Don't forget to do those pluses and minuses. That's going to be the part that people forget. Okay, there's a whole page of these types of problems on the test. And last year, a lot of people gave me positive answers for every single one. They didn't think about those positives and negatives. So, all right, see if you can finish that up there. Do a little Pythagorean action for me. And let's see if we can get values for sine and cotangent. Yes, did I make a mistake? Awesome. Help me out. Oh, I'll flip that. I did tangent, didn't I? Thank you. Thank you. Thank you. Good catch. Right. I did tangent. We need to go adjacent over opposite. So that would be 2 over root 21. We can't leave it like that. Bring my negative down. That's going to be 2 root 21 over 21. Thank you for that. Much appreciated. There's that sun glare coming in. That's it, guys. You did awesome today. I threw a whole bunch at you. If like 60 or 70% of it stuck, then you're in good shape. Homework assignments on Canvas. I'm going to give you a review over the first 3 sections on Friday. You'll have the whole period to work on it in class and get questions answered, okay? Thank you. Thank you. You guys are awesome.